Hey everyone, this is Derek. In this video, we're going to look at finding the area bound by two curves again, but this time we'll have to find the limits of integration. So for this one, we're supposed to find the area completely enclosed by this line and then this parabola, approximately 2 decimal places. So I graphed this in Desmos just so I could kind of show it. But even without this, I would be looking for the place where these two things are intersecting. That's what I'm going to be, that's where I'm going to want to look for my integration. And so what I'm looking for is those 2 points of intersection, because that's going to be the place that's going to be bound by those two curves. So to do that, we would just set this up in factor. So we'd have 3x minus 4 equals negative x squared plus 6x. I don't like negative x squareds when I don't have to have them, so I'm going to bring it this way, make it easier to factor. So it'll be positive x squared, so I'm subtracting 6x over, so that will give me a minus 3x, and then that minus 4 equals 0. And then from there I will factor, so that will be x minus 4 and x plus 1 equals 0. And so then x equals 4 and x equals negative 1. So what that will do is give me what will be my limits of integration when I go to set my integral. So we're going to be integrating from negative 1 through 4 right there. So say we didn't have this graph, because the next thing I'm going to do is the bit back. Let me grab that piece. So here's where we're heading next, is where we're going to f of x minus g of x. But just because they called this one f and this one g doesn't mean that's actually the same order as this. And in this case, it's not. Here we got to go blue one minus red one. So that's going to be g minus f for how these are labeled. So we just have to be careful that we're getting the right curve. If I didn't have this graph, how would I know which curve was the right curve? Well, I could grab an easy value like x equals 1, say. And if I put that in f of x, so if I find f of 1, that would be 3 minus 4, so that would equal negative 1. If I put that in g of x, that would be negative 1 squared, the negative of 1 squared actually, plus 6 times 1, so that would equal 5. So you can see the blue one comes out taller, g of x comes out taller than the red one, f of x. So we're going to have to go blue one or g of x minus f of x. So to set my integral, we're going to go from negative 1 to 4, and then whichever one I just said, let's see, it is the parabola minus the line. So that is what we would be trying to find. If I kind of clean that up a little bit, let me rewrite that. So all I did was clear my parentheses. I went 6x minus 3x, so that gave me that 3x, and then minus that negative 4 gave me the 4 there. And then I'll integrate, so we get negative x cubed over 3 plus 3x squared over 2, and then plus 4x evaluated on negative 1 to 4. And then after that, it's a bunch of arithmetic. And so again, I'm not going to write it all out here. I'll just refer you to the notes, and these are available online right next to the video. But so here I am plugging in the 4 to that big mess. Here I am plugging in the negative 1 to that big mess. And then I kind of cleaned up the arithmetic so you could sort of see how it reduced, and I threw it in a calculator from there. You could also throw it in a calculator right on that line, but the more you try to type, it doesn't go that good. So I would clean it up a little bit at least. This one is similar, but it's actually easier. So f of x is the red one in this case, and g of x is the blue one in this case. And so again, if I wanted to, I'm trying to find the area completely enclosed by these. So I wouldn't have that graph. So I would set x squared equal to cube root x. I would probably bring the cube root over, so I would have x squared minus, I think I'm going to write that as a 1/3 equals 0 now. And then I'm going to do some super sneaky factoring, but you're going to see it's going to come out to 0 and 1 every time on this problem, so it's not like you're going to have to probably recreate the sneaky factoring on your own. This 2, I'm going to call that 2 a 6/3 minus an x to the 1/3 equals 0. So now I can factor x to the 1/3 out front. And that's going to leave me x to the, taking 1 out of 6 would leave me 5/3, minus x to the 1/3, taking that out of there, just leaves me a 1 equals 0. So here I have x to the 1/3 equals 0. That's just cube root of x equals 0, so that's x equals 0. And that's what we're seeing right there. That's that point intersection. And then here we have x to the 5/3 minus 1 equals 0. So bringing that over, that means x to the 5/3 equals 1. And then that would have to be a 1, right? Because 1 to the 5th is 1, and then cube root of 1 is still 1. And you can also think of this as, if you're having to solve this like this did something more interesting, I would be raising both sides to the 3/5, because that makes this 15 over 15, which is 1, and that would do this math. But again, in this case, that ends up 1. So that's that other point of intersection. And then the other thing you would want to do is, again, you would plug in, pick a number between 0 and 1, so say 0.5 or 1/2, and square that, you get 0.25. I'm not sure what the cube root is, but it's bigger than squared. And so you'd find that the blue one is the larger function, or g of x is the larger function. So we would integrate from 0 to 1, because that's what we found there, of cube root x minus x squared and dx. And so again, this is like a 1/3. Probably should just wrote it that way. And so if I do 1/3 plus 1, that will be 4/3. So that should give us x to the 4/3 over 4/3. And then that will be minus x to the 3 over 3, evaluated from 0 to 1. And so the 0 will drop out, so for this one we're just going to have to do the 1. So 1 to the 4/3 would be 1 divided by 4/3, which we'll flip in just a second, and then minus 1/3. We plug in the 1 here. And then this, remember, comes up and flips over, so 3/4 minus 1/3. And again, this is 2 decimal places. So once you're here, if you're good at typing in the calculator, you can just do that. And then if you type this in as well, you should get 0.42.